Maths channel. I'm now answering question number 6 from the October-November 2020 Cambridge paper 5 variant 2. This is the statistics S1 paper from the 9709 syllabus. And this question is about permutations and combinations. And it's one of those topics that many students have some issues with. So here we have a question that says, Mr. and Mrs. Ahmed, along with their 2 children, and Mr. and Mrs. Baker, along with their 3 children, are visiting an activity center together. They will divide into groups for some of the activities. In how many ways can the 9 people be divided into a group of 6 and a group of 3? So you have these 2 people and 2 children, these 2 people and 3 children. As you can see, that makes 9. 6 plus 3 is 9. Now, how many ways can these be divided into a group of 6 and a group of 3? Okay, so we have 9. 1, 2, 3, 4, 5, 6, and we have 3. 1, 2, 3. Want a group of 6, and we have a group of 3. Now here we don't have an arrangement. They're not being arranged. They're just being divided into a group of 6 and 3, and they're not arranged within those groups. So we won't use like the permutations here. We'll use combinations. So for the group of 6, we can say we have to choose from 9 people. We have to choose 6. Okay, we don't have to arrange them. Just choose them. And then from these 3 remaining, we've got to choose 3. Okay, from the 3 remaining, because we've already chosen 6 of them, there's 3 left, and we have 3 of them to choose from 3. So basically, it's going to be, the answer is just going to be 9C6. Okay, we could have also done it the other way around. We could have said, okay, we got to choose 3 from 9, and the rest of them, we've got 6 to choose from 6, and we will get the same answer because 9C3 and 9C6 gives you the same answer. Okay, and I can show you that. So here we have, let me just, why is it doing this? Okay, so we have 9C6 equals 84, right? Of course, 3C3 will be 1 anyway. So this is going to be 84. The answer is going to be 84. And we can see that even if we did it the other way around, if we did 9C3, okay, 9C3 also gives us the same answer, 84. Okay, and of course 6C6 gives us 1. So the answer for the first question is 84. Okay, so there's 84 ways that can happen. All right, for part B of the question. Now part B, I've just taken this, I've taken this information and put it down here so that we don't have to keep scrolling up and down. So it says, Mr. and Mrs. Ahmed with their 2 children, same question. So it says 5 out of the 9 people are selected at random for a particular activity. Find the probability. Now this is very important. Find the probability. So you see the word probability, you know you're going to have a fraction. You're going to have the total number of outcomes and denominator and so on. So keep that in mind. A lot of people, they don't realize it says probability and they just find the number of ways without finding the probability of that number of ways. So it says find the probability that this group consists of this group of 5 people. So it says 5 out of the 9 people are chosen at random for a particular activity. Find the probability that this group of 5 people contains all 3 of the Baker children. So first of all, we're going to see the total number of outcomes. That will be our denominator. Total number of outcomes is basically just choosing 5 from 9. Okay, so we're going to choose from 9 people, 5 people. We're not going to arrange them, we're just going to choose them. Okay, so that's going to be NC5. So NC5, that gives you 126. So there's 126 ways of choosing 5 people out of 9. Okay, then it says find the probability that this group of children group of 5 people contains all 3 Baker children. So you're going to have 1, 2, 3, 4, 5. but the Baker children are fixed here. This is like, you know, and we're just selecting them. We're not going to arrange them. Okay. So we're not selecting them. So we're not going to then, you know, kind of like mix and match them around and stuff. We're just selecting. It's not arrangement. So we're not going to do with permutations. We're dealing with just combinations here. So we have, for this part here, we have to choose out of the 3 Baker children, 3 of them. So that's just going to be one way of doing that, because all 3 of them. And then we've got now we have to choose out of the 5 out of the 9 people. So we've got 6 people left, okay? Because we've chosen 3 of the children. So there's 6 people left to choose from, okay? So these 2 spaces are for the 2 remaining people out of the 6 that have not been chosen. The 3 Baker children already taken up. That leaves us with 6 people left, okay? And from those 6, we have to choose 2. Okay, from those 6, we have to choose 2, and that should give us the right answer. So you're going to get 6C2 as an answer. So 6C2 gives us 15. Okay, so now we got to find the probability. Right, so don't forget this is a question about probability. Okay. Okay, so now to find the probability, we have the number of successful outcomes, which is the number of ways of, you know, these 5 people containing all 3 Baker children, which is 15, divided by the total number of outcomes, which is 126. So you get that, and we can simplify to answer at the end 15 divided by 126, which gives us 5 over 42 in its simplest form. So here we have the answer for this question, part B. Okay, now we're going to move on to part C. Now it says, again, I've copied and pasted the information from the beginning of the question. It says all 9 people stand in a line. Find the number of different, now here we have the word, a keyword, arrangements, which means we've got to not just choose them, we've got to arrange them as well. So we're going to be dealing with now permutations in this question. So find the number of different arrangements in which Mr. Ahmed is not standing next to Mr. Baker. Now, this is a classic type of question. Okay, when you want to find the number of ways that 2 people or 2 items cannot be together, you have to basically find the number of ways that they can be together and subtract that from the total number of arrangements that you can have. So we're going to have the total number of arrangements. So we got the total arrangements. Okay, the total number of arrangements minus, okay, Mr. Ahmed and Mr. Baker together. Okay, and that will be our answer. So this will be equal to the total arrangements minus the arrangements where they're together. Okay, where they are together. All right, so first of all, the total number of arrangements. Let's find that. The total number of arrangements. Okay. What's that going to be? Well, we have 9 factorial, basically. Okay, that's 9 factorial. In fact, I can just write this here. So this will equal 9 factorial, because there's 9 ways of choosing. You have 9 times 8, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All 9 of them, right? Now, minus the arrangements where they're together. So let's look at them when they're together. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say they're both together in this position here. That's basically, you can say 1 block, right? And then you have 1, 2, 3, 4, 5, 6, 7. So basically, you can treat this as 1 block. So you have 1, 2, 3, 4, 5, 6, 7. It's like 8 objects that can be arranged amongst each other, right? So you have the total number of arrangements, which is 9 factorial. And then you have basically, here we got these can be arranged in 8 factorial ways. Okay, 8 factorial ways, because, you can arrange them, have 8 factorial times 7 times 6 times 5 times 4 times 3 times 2 times 1. There's like 8 objects here because these have to stay together. So you can treat that as one object. However, these two can be switched around. You can have A there and B in here. So amongst these together, you can have 2 factorial ways of arranging them, right? Because you have, they can switch places. If there were 3 things that were kept together, you would have 3, factorial ways of arranging them amongst themselves. So you have 9 factorial minus 8 factorial times 2 factorial. Okay. And that should give us our answer. Okay. 9 factorial, which is the total number of arrangements, minus 8 factorial times 2 factorial. So you have 9 factorial. Factorial button is over here if you're not sure. Just press shift and this button over here. Minus 8 factorial times 2 factorial, which is just going to be 2. So that gives us 282,240. 282,240 ways. Okay, so that's choosing and then arranging. Okay, choosing and then arranging. Okay, so there we have the answer to part C. Now, the question that was actually asked by the student, he was asking, was part D, but of course I wanted to answer the rest of the question as well for completeness sake. This is actually the question that he was asking. It says, find the number of different arrangements in which there is exactly one person between Mr. Ahmed and Mr. Baker. So let's set this up. It says 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to have Mr. Ahmed and then a space and then Mr. Baker. Right? So there's one person between them. Okay. So now what we can do here is we can deal with it in the following way. Now, what I'm going to do here to make it a bit clearer, let me just make this a bit thicker so it shows up better when I group them. So if I choose these two and I group them, just to give you a bit of a visual kind of understanding. Okay, so these two now are grouped together. Whoops. What's up in there? Get rid of this part. These two are now grouped together. Right. So they're grouped together with somebody between them. Okay. Now, what we can do here is we can think about how many ways that these can be arranged in this region. So you can think about it in a few different ways. We can say that we have to choose one person, okay, one person from 7 people, because these two, of course, it can't be this is Mr. Ahmed and Mr. Baker. So those two have to be in these two positions. There's 7 other people to choose from. One of them has to be chosen to stand between them. So from 7 people, we're choosing one person to go between Ahmed and Mr. Ahmed and Mr. Baker. Right? So that's one thing. Then we've got to think about how many ways that this can be arranged in, this amongst themselves. Okay? So what we can do here is we can say in 2 ways. We can think about it in 2 ways. We have, these people, there's not a fixed person that's here. It could be any one of those other 7 people. So we have 7, it's 1, 2, 3, 4, 5, 6, 7 people to be arranged amongst themselves. Okay. Those 7 people can be arranged in any, different. So 7 factorial times 6 factorial times 5 times 4 times 3 times 2 times 1 factorial. Okay. And then, 7 times 6 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 7 factorial. That's what I meant. And then these two could also swap over places. So we're going to multiply that by 2. Okay, the 7 factorial could also be understood in a different way, where you can say, okay, A and B, this Ahmed and Baker can be in this position. That's one place it can be in. That's one possible place. That's 2, 3, 4, 5, 6, 7. Okay, so it's like, that's how we could also understand this 7C1, basically. All right, so we have one person chosen to go here. These two can be arranged either this way or that. It could be B, A, or A, B. So that's where the 2 comes from. Okay, and 7 factorial is for these 7 people to be arranged in these 7 spaces. Okay, so 7C1 is 7 times 2, which is 14 times 7 factorial. You can just use a calculator to calculate that. And we have, so we're going to have 14 times 14. So we're going 14 times 7 factorial. That equals 70,560. 70,560. And there we have the answer to part D. And that concludes this question. I hope that was clear. It's one of those topics which is kind of a bit confusing, and you have to do lots and lots of practice of looking at different examples and scenarios and different types of questions. You have to be careful about the words. Again, here we had arrangements, so we use permutations. Okay, as it says selection, then we don't arrange them, so we use combinations and so on. So you have to look at all the different types of questions that have come up in the past. And, with a lot of practice, you will be able to know exactly what to do. So this is one of those topics you really have to practice a lot before the exam to see lots of different examples and situations. And so you can quickly know what to do. Okay. It's very easy to mess up in this topic. Anyway, so that concludes this question and concludes this paper. And any other questions from this paper that you want to watch, you will find them in the playlist that is going to appear at the top right of the screen. If you don't find the question you're looking for, you can just send me a message and I will try to answer that as soon as possible. You can just send it on the channel, for example, and I will try to answer that as soon as I can. Other questions from this topic of permutations and combinations from S1, you'll find in the playlist in this section over here. You can subscribe to my channel by clicking on this link, and the video that will appear on this region will tell you how to use my channel in an effective manner. Thank you for watching and see you soon.